These are the answers to the Chapter 8 review. I'm going to work them fairly quickly so this video doesn't last too long. Number 1, if I cross multiply, I'll get 2x is equal to 32. Tells me x is equal to 16. For the second one, I will get x times x plus 1 is equal to 3 times 4, which is 12. Distributing, I get x squared plus x equals 12. Because it's a quadratic, I want everything on one side. So x squared plus x minus 12 is equal to 0. I need two numbers that multiply together to give me negative 12, add together to give me 1. That would be 4 and negative 3. So x plus 4 times x minus 3 is equal to 0. One or the other factors has to be equal to 0. So x equals negative 4 or x is equal to 3. If I try both those answers, negative 4, I will get negative 3/4 equals negative 3/4. If I try 3, I'll get 1 equals 1. So both of these are good answers. For number 3, I'll do 2 times x plus 15 is equal to 5 times x. Distributing out my 2, I get 2x plus 30 is equal to 5x. Subtracting 2x from both sides, 30 is equal to 3x. So x is equal to 10. 2 over 5, is that equal to 10 over 25? Yes, it is. Complete the sentence. If 7 over 2 is a over b, well, notice that the 7 and b have to be across from each other. So here I'll make the 7 and b be across from each other. The 2 and the a have to be across from each other. So my answer is going to be 2 over b. For number 5, the t and the 5 are across from each other, so I'll put the 5 across from the t. The 3 and the s are across from each other. My answer is s over 5. 6 is that special case that I kind of told us about. 5 plus p over p must therefore be equal to 4 plus q over q. Geometric mean of two numbers, how do I find it? I multiply those two numbers together and take the square root. That's the square root of 96. I know that breaks to 8 and 12, which breaks to 4 and 2, 6 and 2, 2 and 2, 3 and 2. Writing this in order from smallest to largest, I get a 2, a 2, a 2, a 2, a 2, and a 3. 1, 2, 3, 4, 5 2s and a 3. If they become pairs, they can go outside the radical. These become 1 and go outside the radical. These become 1 and go outside the radical. I have 2 times 2 outside the radical, which is 4. 2 times 3 inside the radical. My answer is 4 times the square root of 6. Same with number 8. I'm going to do 6 times 10, and then I'm going to take the square root, because that's how we get a geometric mean. The square root of 60, which is 4 times 15, which gives me 2 times the square root of 15. Number 9, because these two lines are parallel, that means the two triangles are similar. I want to find CE. So 10 over 4 is equal to 8 over CE. 10 CE is equal to 32. CE is equal to 32 tenths, which I'm just going to call 3.2. If you wanted to call that 16/5, that would make me quite happy. On the next one, these two triangles are similar. And so now I'm going to say, I'm looking for EF. I'm going to say EF over FD, which is 14, is going to be FG, which is 6, over FH, which is 10 plus 6, which is 16. So 16x is equal to 6 times 14. Well, let's see. 2 goes into 16 8 times, 2 goes into 6 3 times, 2 goes into 8 4 times, 2 goes into 14 7 times, and so 4x is equal to 21. X is equal to 21 over 4. Clearly you could have said 6 times 14 is 60 plus 24, which is 84. 84 over 16. I believe 4 go into both those numbers. 21 over 4. Doesn't matter how you get there. My answer should be x is equal to 21/4. All right, are the triangles similar? Well, I've got two angles here already. I also have here and two angles that have to be congruent because they're the reflexive property, they're the same angle. So by angle-angle similarity, spell it correctly, similarity postulate, I would say yes, the two triangles are similar. And so I want to solve then for x. I would say 5 over x is equal to 7 over 3. There are many other proportions that you could use to accomplish the same goal. Here I get 7x is equal to 15, so x is equal to 15 over 7. For number 12, look, I have these two parallel lines, so I have corresponding angles, and then I have either more corresponding angles or the reflexive property. So this one is also congruent. These two triangles are also congruent by the angle-angle similarity postulate. This time I'm going to say 10 over x is equal to 15 over 15 plus 24. Notice I'm going for the whole big side. I have to go for the whole big side. So 15x is equal to, well, 15 plus 24 is 39 times 10 is 390. So x is equal to 390 over 15. And let's see, I know that 5 goes into both those numbers. I know that 3 goes into both those numbers, so I should get an actual value here. Let's see, so my answer is going to be, has to be a 2 and a 6, right? 26. 26 times 15 is going to be 390. Okay, let's find the similarity ratio. I've got ABCD is similar to WXYZ. Notice I've got BC and XY. Well, look, BC is 3 and XY is 6, so my similarity ratio has to be 3 to 6, which is going to be 1 to 2. Well, if the ratio of ABCD to WXYZ is 1 to 2, then the ratio of those backwards would have to be 2 to 1. I know that, by the way, it looks certainly like this is going to be a trapezoid. I think I could prove that pretty quickly, but I'm not going to right now. Let's see what S is. S matches up with XW. It should be half of that, so S should be equal to 3.5 or 7 halves. T would be 7, double 3.5, and U would be 5. Find the ratio of the perimeter of ABCD to the perimeter of WXYZ. Well, if the scale factor is 1.2, the scale factor of the perimeter, the ratio of the perimeters has to be the same. It also has to be 1 to 2. And for that matter, the ratio of the areas has to be 1 squared to 2 squared, which is 1 to 4. Are the triangles similar? Well, I only see one angle for number 18. I've got an angle. If these two sides could be proportional, I would be fine. 3 to 4 is not the same as 2 to 6, but I will say that 3 to 6 is the same as 2 to 4. They're both 1/2, and so if I'm careful, I can say yes, they are by the side-angle-side similarity theorem. And let's see what I would have. I'm going to go O M N, doesn't matter how I start, it's going to be similar to O, I went up the small side first, P, Q. Number 19, I see one angle, I don't see anything else, and I don't see anything stopping C from being here, and so there's no way to know if these triangles are similar or not, so I'm going to put not enough information. Number 20, these triangles are going to have to be similar because I have corresponding angles postulate giving me two angles, so they're going to be similar by the angle-angle similarity postulate. And let's see, I would then say triangle VUT must be similar to triangle VRS. Other ways you can write it, but V has to match up with V, U has to match up with R, and T has to match up with S. All right, this last one, Well, one thing I know for sure, a lot of different ways to do this, but I see a 3-4. Hopefully by now you know this is going to be a 3-4-5 right triangle. This is going to be a 6-8-10 right triangle. Clearly we have a scale of 2 to 1. You could easily use side angle side similarity postulate, but just as easily all of these are in a 2 to 1 ratio or 1 to 2 ratio depending on which side you go. So I'm going to call this the side similarity theorem. And I am going to go from smallest to large. So I'm going to say triangle, the one on the right, C, what is that letter? A, B, C, D, E. So C, D, B, going 3, 4, 5 is going to be similar to triangle A, E, B, 6, 8, 10. All right, we're going to use this figure to complete the statements. YO, which is this piece here, to OB, which is this piece here, is the same as AE to ER. Number 23, YB, this big section, compared to OB, this section, is the same as what to ER? The answer must be AR. Number 24. Something to AE is the same as YB to YO, so it must be AR. 25. dy to yo, oops, wrote that incorrectly, let's try that again. dy to yo is the same as dA to AE. 26. dr, the big triangle, compared to what is the same as dB compared to YB. Well, clearly the answer must be AR. And something to AE is the same as DO to YO, and here the answer must be DE. One of the things they didn't do on here is they didn't show this third leg of a triangle here. All three of these triangles, number 1, number 2, which is the bigger one, and number 3, which is the huge one there, they're all similar, and so I got to be real careful. Let me show you one more thing that they might ask. They might say dy to yo is the same thing as ya to what? Okay. dy is this left leg of the little triangle, and do or yo is the bottom part of this little triangle. So ya is, or the left part, sorry, the left part here. We've got this little piece here. Let me change this dA to do. So now I've got this piece of the triangle compared to the whole bottom part of the triangle is the same as the bottom of this triangle here compared to the whole bottom of the triangle here. If you don't see that, please come see me, because I need us to understand that there are similar triangles besides the sides. I believe there's one on the quiz or test that will ask us about the bottom sides. Break these things up into triangles for me, right? You've got this triangle DYA, you've got this triangle DOE, and you got this triangle DBR, and they're all similar to each other, and you can match up the sides accordingly. Find the value of x. This is the triangle angle, or number 28 is a triangle angle bisector theorem, which tells us that 9 over 24 is equal to x over 18. So let's do a little bit of simplifying first, might help us out. I believe 3 goes into 9 3 times, 3 goes into 24 8 times. So 8x is equal to 3 times 18, which is 54. Dividing both sides by 2, I get 4x is equal to 27. So x is equal to 27 over 4. All right, the next one, I can still do the side splitter. The left-hand piece, x, compared to 10, is equal to the right-hand piece. Well, how much more do I need? Or what is the value of this? I don't know, but in terms of x, it's 18 minus x divided by 12. So I'm going to say 12x is equal to 10 times 18 minus x. 12x is equal to 180 minus 10x. So 22x is equal to 180. Dividing both sides by 2, 11x is equal to 90. So x is equal to 90 divided by 11. And one more triangle angle bisector. Now I get 12 over 16 is equal to x over x plus 5. Please remember you can do a lot of different ways to set up these proportions. That's just the way it works for me. 12 over 16 is the same thing as 3 over 4. You don't have to do that first. It just makes it easier for me with the numbers. So I get 4x is equal to 3 times x plus 5. 4x is equal to 3x plus 15. Subtracting 3x from both sides, x is equal to 15. 12 over 16 is the same thing as 15 over 20. The perimeter of a rectangle is 98 inches, and the ratio of the length to width is 4 to 3. I put a 4 and a 3, but notice it's not the scale itself is for the scale factor, not the numbers themselves. Whenever I'm solving these problems, put an x out here. So I've got 3x and 4x. Now, the perimeter of the rectangle is 98, and the perimeter is 2 times the length plus 2 times the width. 4x plus 3x plus 4x plus 3x is equal to 14x. Substitution property equality says that 14x is equal to 98, so x must be equal to 7. Let's see if that makes sense. This would therefore be 28. This would therefore be 21. X is 7, 28, 21. 28 plus 21 is 49. Double 49 is 98, which is my perimeter. ABC is similar to DEF. Find the value of x. This is messed up because look at these numbers. Isn't that just nuts? I think I'm just going to allow you to skip this one. If you want to pick a number and go for it, that's fine. But that's why I should always proofread these before I give them out. Number 33. The ratio of one side of ABC to a corresponding side of similar DEF is 4 to 3. Okay, so this is a triangle, and I don't know if it's a right triangle or anything else, but I do know that if this is, I kind of wrote this backwards, right? If this is ABC, this would be a 4 and this would be a 3. The perimeter is 96 inches of DEF, which is the smaller one over here, right? So DEF, the perimeter, is equal to 96. So the ratio of the perimeters is the same as the ratio of the angles. So in this particular case, 4 to 3 has to be the same as, remember 3 is the DEF, and here the DEF is 96. Whatever the perimeter of ABC is to 96. So 3x is equal to 96 times 4. Well, I'm going to divide by 3. Before I multiply by 4 and divide by 3, let me just divide by 3 first. 3 goes into 96 32 times. So x is going to be equal to 32 times 4, which is 128. So my answer is going to be the perimeter of ABC has to be 128 inches. Hopefully this helps you. If you've worked these out and still don't understand what I did, come see me and let's get these right before the quiz. Study hard.